Oh my god. All right. So in this tutorial, we're going to go over interrupts. Interrupts are really important, especially when you're writing a program that talks to multiple devices. You cannot just constantly go in a loop and check, for example, if a sensor has data for you. Like that's an example of where you would want to use interrupts. Let's just get into it. So interrupts. Let's say we want to make this program. So this is an example program that I'm going to start off. So let's say we want to make a program that user presses a button and then we turn an LED on when they press a button, right? So let's go here. So the basic implementation, this is a polling-based implementation, is that in a loop we can constantly get the state of the button's GPIO line status, and then we can set the state of the LED to the state of the button. So when you press the button, that button changes the state of the GPIO line, and then what happens is that the LED will change its state to that state, right? So this is the schematic that we have. So on the tutorial board, we have, for example, this is the example of a green switch. So the green switch gets pulled up to 3v3, right, when you press it. So it basically shorts this line. And this button 1 line goes to 3v3. And where's button 1 connected to? Well, it's here, right? PA7. So it gets connected to PA7. So the PA7 GPIO will be pulled high, right? So what should I set the state of this resistor, like internal resistor of this PA7? Should it be pull up or pull down?
Pull up.
So if it's pull up, when this button is open, the state of the line is high, right?
Yes.
When this button is closed, the state of the line is still high because it gets pulled up to 3v3. Right? So it should be pulled down. Because when this button is open, it should be the opposite of what this button does. And what this button does is that it pulls this line to high, right? So you need to actually configure it pulled down. And then, so I just brought these to you, but usually when you're writing firmware code yourself, you have to actually look at it, at the schematic itself. So how do you find the schematic? Well, you just go to our hardware repo. So github.com pw/midsun hardware. So I'm just going to change this link to hardware. So this is the hardware repository. You can see all of the MS12 and MS14's current hardware. So over here, you just look at the tutorial board, right? So project outputs, PDF. And when you take a look at this PDF, it exactly has what you need. So as you can see, it's a pretty simple board. It only has this much block diagram, like what's it called? Schematic in it. So this is the mezzanine, right? This is the connector that connects to your controller board. As you can see, these lines have been, like, we're not using many of these pins because there's not that many components on this board. However, we're using these pins and these pins and these pins. And they're all connected to these, like they're basically labeled, and then on the other side of the schematic you can see where those labels go to, right? So over here we have like a potentiometer. That potentiometer goes to PA0. So in the next tutorial ADCs I'm going to actually use this. And then you can see that there's two buttons. There's the button, the green button and the yellow button. The green button goes to button 1, yellow button goes to button 2. Where does button 1 and button 2 go? Take a look at the mezzanine, PA7 and PA6, right? So let's go to the next part. So here I'm going to demo a button press using the polling method. Let's take a look at the code itself first. You don't need to start filming. I'll let you know. Button press polling. So as you can see, I have the GPIO addresses, right? So LED, there's two LEDs. There's one a blue LED and one yellow LED. So if you take a look at the schematic, you can actually find them. So these are, I'm referring to the LEDs on the tutorial board itself. So you can see the blue LED is connected to PB3, right? Oh yeah, over here. So LED blue PB3. And then over here, you can take a look at the yellow LED, which is PB4. PB4, right? And then now we go to the button addresses, which is where the buttons are connected to, because we need to read from the buttons and write to the LEDs, right? So this is button 1, button 2. We're just naming them switch 1, switch 2. Really, they are buttons. I mean, I guess they are switches as well. I don't know. And then, so button 1 is PA7 and button 2 is PA6. And you can see that the green button is button 1. So button green, pin 7, port A. Button yellow, port A, pin 6, right? So I set the LED settings to be direction out. Their default state, I want them to be high. And then we're not using any peripherals here. And then the resistor status, I just want it to be none, right? So what else do we do here? Okay, so I initialize the pins. Let's take a look at the button. Wait, is this interrupt or polling? I'm getting the state and I'm setting the state. So this is actually interrupt. Sorry, polling. So the button settings, this part is actually important because the direction is in because you're reading from the button states, and the resistor is pull down. If this were pull up, it wouldn't work, right? I can actually change it to pull up later just to show you guys. So I just loop in a while loop. I get the state of the green button, and then I set the state of the blue LED to whatever the state that the green button was holding. And I get the state of the yellow button, and I set the state of the yellow LED to the state of the yellow button, right? So now let's try running this project. So now you can film me. Project equals.
I think you need a connector.
A connector?
To the button.
Oh yeah, you're right. So are you filming this?
Yes.
Okay, so get close. So this is the controller board. I'm just gonna put it on the tutorial board. There we go. All right. So the controller board is sitting on top of the tutorial board, and then bring this a little bit closer. These are the LEDs. So LED 1, LED 2. These are the switches. Switch 1, switch 2. So when I press this switch, I get the state of this switch, and I set the state of the LED to that, right? So let's hope that this tutorial board works. Otherwise, I would have to go downstairs and get another tutorial board. Tutorial board button polling. So that's the project that I'm running. Okay, you can see that it programmed. So come close, come close, come close, come close. All right. So in this board, the hardware actually brought it up correctly. So the yellow LED is actually yellow. The blue LED is actually blue. We have the green button and the yellow button. So let's see if this works, right? And also these pins are actually, these LEDs are mapped to the same pins that these LEDs are connected to. So you can see that like both of these will turn on. So let's press this. Good. So when you press it, you can see that this switch basically possibly opens up the relay, so the button gets pulled down. Same with this switch, right? So that's how that program works. All right. So let's get to the next part of this presentation. So that method of getting input was polling. You basically are constantly looking for the status on the input, like every single status, every single second you're just going there, you're like, hey, what's your status, what's your status, what's your status, and you constantly, whatever that status is, you just set the button, the LED's state to that state. But if your program has to do more than one thing, it becomes really, really hard to manage. So let's say you're talking to three different buttons, and at the same time you're receiving CAN messages, and you're also possibly like sending debug stuff to the computer, right? So there's no way you can, in a giant while loop, just go and check for this, and then go and check for that, and then check if the user pressed the button, and then go and like send a message, and then come back and see that the user pressed the button. So that sequential execution of the program will not make sense here because your program is doing too much, right? So the way that we get around it is by interrupts. So let's get to interrupts. So on the hardware side, there's actually a physical occurrence that triggers the CPU to stop its execution. So usually this is a really simple diagram. It's literally as simple as an interrupt gets. So there's usually like one line that goes to your CPU, and when you like, for example, press the button or something, this line will change the voltage level, and the CPU catches up that change in this voltage level, right? So how it works is that you configure your MCU to accept an interrupt. So you basically tell your CPU that if this changed, do something. So some special function gets called, and that function we just call it a callback. When that interrupt goes off, right? This callback is like an informal name, like that's just the name that I'm giving it. The formal name for it is actually an interrupt service routine. This is basically that function that gets called. And then when the interrupt condition occurs, your CPU stops whatever it's doing and then runs that function. And then it goes back to whatever it was doing previously, right? So that's how interrupts work in general. This condition is also configurable. So you can tell your CPU to, for example, trigger this interrupt when that line goes high, like a rising edge or a falling edge, or you can have it trigger on both, so like both the rising edge and falling edge, right? So you can configure the GPIO pins to be interrupts themselves, which is pretty cool. Wait, oh, the screen hasn't updated. So you guys are seeing like the last screen. Oh well. So you can configure the GPIO pins to be interrupts themselves, and the it finally updated. The function for it is the library that we have is GPIO_IT, and IT stands for interrupt. So let's take a look at a similar program that uses interrupts. So the next program will be very similar to the original program that I showed you guys, and that is button interrupt. And I'm going to go to main.c. So here you can see the same type definitions and LED and button definitions. However, I'm using the GPIO_IT library, right? Let's take a look at what this library is, GPIO8. So you first initialize it. So this possibly like sets some configuration bits on the MCU to make sure that it accepts an interrupt. And then you register an interrupt. And as you can see, it takes like a GPIO address. And then it takes some interrupt settings. So I'm going to show you, for example, the interrupt settings that I'm using for this interrupt. And then it takes an interrupt edge. So if the edge is falling or rising, so you can just take a look at this. So edge is rising, edge is falling, or rising, falling, right? So that's your three different options. This is an interrupt callback. So this is the definition of that callback. So it's a function that returns nothing. So it's void itself. And these are the inputs to it, right? By the way, this is how you type def a callback. And then you can trigger the interrupt manually yourself in the software. And then there's also this mask interrupt function. So it masks the interrupt for the given address if masked is true. It enables it if masked is false. So let's say based on something, sometimes you may want to disable the interrupt momentarily. For example, to debounce a whole bunch of buttons. Let's say the car starts driving and there's some vibrations, and those vibrations trigger some of these interrupts, right? So there's some technique that we use to debounce that line, and that's basically, so you guys can take a look at debounce.h file to see what that does. That's kind of out of scope of this video. So let's go back. So where were we? Button press interrupt. Are you taking notes?
Yeah.
You'll have this video, you don't have to take notes. Okay, so here we have the callback, right? So what is happening here is that we just toggle the state of the LEDs. The LEDs initially we set their state to be high, right? And then where's my interrupt settings? Okay, so the interrupt settings, you can see it takes a type and it takes a priority, right? So interrupts themselves have priorities. There's high, normal, low. Let's take a look. So there's high, normal, low, right? So high priority means that this is a really, really important interrupt that needs to get handled first, right? So usually when your program is running, there may be multiple interrupts that may trigger at the same time, right? So your CPU has to decide which function to call first, right? So, or if it's, for example, running a function that's for like a low priority interrupt, if a high priority interrupt comes in, it'll stop running that function, goes to high, and then comes back to that function, right? So that's how that works. And then we initialize the pins, and then so these are for the LEDs because LEDs are output. However, your buttons are input. So over here we pass in the interrupt settings that defined above, and we change this. This is a rising edge interrupt. So whenever your line voltage goes high, this interrupt will trigger. For the second button, the yellow button, we do falling. So whenever your line voltage goes low, this interrupt runs, right? So now let's run this, see what happens. I would want you to help me here. Thank you. All right, so we run this. All right, so there we go. Okay, so we programmed this board with this program that we just saw, and okay, that's good. So what you can see is that the initial state of the LEDs is high, so that's pretty nice. And then we press this button. If you remember this, the state of the green one was rising or falling? But basically what happens is that when I let go, this takes place, right? The other button is the opposite. So when I press this, it takes place, right? So that's how it works, right? So one of those interrupt functions, for example, in this case, let's take a look back at the yellow one. So yellow was falling edge, right? And by default, these are the state of the lines are high, right? So when you press this, you're actually pulling the line down. Okay. So when you're pulling the line value low, whenever I press a button, the line value goes low. So whatever LED that is whatever button that is falling should trigger first when I press the button, not when I release it. So you can see that's the case. This guy, however, triggers on the rising edge. So when I press it, nothing happens. When I release it, it works, right? So I'm gonna go ahead and change this falling to rising falling for the yellow LED. Rising falling, right? So let's program this again. So which LED did I change? Yellow. So now when I press this, it toggles the state of the LED. When I release, it toggles again. Right? So that's how that works. So whenever the state of the line goes down, the interrupt function gets called. Whenever it goes up again, the interrupt function gets called. And that is how interrupts work. And you guys are going to be using interrupts a lot. So that is it. That was the demo, and that's this tutorial.